All right, here we go. Find an equation of the ellipse with a center at the origin, one vertex at 0, 5, and one focus at 0, 2. And then we're going to sketch the ellipse and label the vertices and the endpoints of the minor axis. So the minor axis being the shorter of the two. So let's start by just kind of giving a rough sketch to help our minds understand what's going on here. So we have one focus at 0, 2. Sorry, our origin is the center, and one focus is at 0, 2. So 1, 2, right around there, meaning our other one has to be at 0, negative 2. Okay. Now we also have a vertex at 0, 5. So 3, 4, 5. There's our vertex up there, and 3, 4, negative 5, our other vertex there. Now we can tell that this is going to be an ellipse that is elongated vertically. That's a vertical ellipse because the foci and the endpoints here are in alignment, meaning that it's going to be wider towards these endpoints. So somewhere along here, we're going to figure out where exactly in a moment, but somewhere along here is where we'll have our vertices out on the minor axis. So this was 0, 5. This is going to be what we're looking for. So something, comma 0, negative something, comma 0, 0, negative 5. And then I'm not going to write those in there because we're kind of out of room, but at 0, 2 and 0, negative 2. And so our equation for this, for an ellipse is, again, x minus h squared divided by the a squared plus, let's see, plus y minus v squared over b squared equals 1. And a squared and b squared, I think I switched them from how you saw them at first, but what it's saying is that whatever your distance from the center of the center of the ellipse to its endpoints along that axis, so along the x-axis, and then the distance from the center to the endpoints along the y-axis. And so here we go. Let's fill in the pieces we know, so that the minor distance on the minor axis from the center to the vertices to the endpoints is going to be, let's call it a, or however we want to do it, but the shorter one. So a squared plus b squared equals c squared. So our shorter one there, whatever a is, and that's our question mark. So that amount, we'll just leave it as a squared actually, plus b squared. So the distance from the center to the focus, and that's a distance of 2, we're given that. So 2 squared equals the distance from the center to the vertices on the major axis. So that's going to be a distance of 5. So we've got 5 squared here. So what is the distance from the center to the vertices on the minor axis? Well, a squared plus 4 equals 25. Subtract 4 from each side, and we'll get the square root, or a squared equals 21, meaning that a is the square root of 21. All right, so our distance from the center out to that minor, the vertex on the minor axis, is going to be the square root of 21. So we could label that that coordinate now. This is the square root of 21. Over here, this is going to be negative square root of 21. That's getting pretty small there. Negative square root of 21, comma 0. And so we've got our good sketch there now. And if you hit that in your calculator, I think it's 4.6 something, or 4.5 something, right around there. But the square root of 21. And now what is sketch the ellipse let's write the equation. So find the equation. We kind of went backwards here. Find the equation of the ellipse. So we know, here's our generic formula. For us, our center, go ahead and write it in red, but our center is on the origin. So it's x minus 0 squared, so that's just going to be x squared. And then y minus 0 squared, so that's y squared, equals 1. And so what's that minor radius and major radius? Well, from 0 to the square root of 21, that distance squared, that's going to be 21. And our distance from the center to the vertex along the major axis, that's a distance of 5. So 5 squared is 25. Remember, this was the square root of 21, and this is 5, being the a and b values here. And so when we square them, we've got 21 and 25. All right, hope that helped.